winter night.
Welcome to day 2 of Fabulous Factoring. Yesterday we took a look at the greatest common factor, and tonight we are going to take a look at the difference of perfect squares. We call that D2PS for short because it's the difference of two perfect squares. So let's get started. And to do that, the first thing we need to do is be able to identify numeric perfect squares and variable perfect squares. I'm going to assume that everyone watching does know the first 10 perfect squares, and actually you should know the first 15, if not 20. So those are the first 10. What does a variable perfect square look like? Now remember, we're taking a look at what am I going to take the square root of that includes a variable that is going to eliminate the square root. That has to be a perfect square. So think about what types of variable expressions might be a perfect square. X squared is a perfect square. X to the 4th, perfect square. X to the 6th, perfect square. Any even power for a variable will be a perfect square. So when we combine the two, we could have something like 4x to the 6th, and that's going to be a perfect square. Everyone out there should know 2x to the 3rd. So to factor using the difference of perfect squares, there are several conditions that must be met. It is called the difference of two perfect squares. Difference meaning subtraction. Two perfect squares, 1, 2, both perfect squares, and then we're all set to go. How do we do that? There are 4 steps to factoring the difference of two perfect squares. The first is, number 1, are there only 2 terms? This can only be used with a 2-term polynomial or a binomial. 2, is the first term a perfect square? Has to be. Is the second or last term a perfect square? Has to be. Is there subtraction? That represents difference in the problem. If all these conditions are met, then in fact we can use the difference of two perfect squares. I'm going to emphasize this again because we really have to be sure. Both parts of the binomial must be perfect squares, 1 part positive, 1 part negative. Find the square root of each term. Notice that one factor is going to be the sum of the square root of each of the terms, and one factor is going to be the difference of the square root of each of the terms. So I take the square root of the first term, add that to the square root of the second term, and then I take the square root of the first term again and subtract that from the square root of the second term. That's a pattern that when we always multiply these kind of binomials, you should have noticed. The middle term always drops out. I would have gotten a squared minus ab plus ab minus b squared. Always the case that the middle terms dropped out, and I ended up with a squared minus b squared. So for example, x squared minus 36, perfect square, difference. So my factors are going to be x plus 6 and x minus 6. One question I always get from students is, does it matter if I write x minus 6, x plus 6? Of course not. And why not? What allows us to switch order like that? The commutative property of multiplication, because this is multiplication between those two parentheses. So you have a bunch of examples there. Why don't you start with the first 3? We'll check in a moment, and then we can go on to the next several. So if you're back with me, here are the answers to the first 3. Hopefully you did well, and what I'd like you to do at this point is take a look at, let's say, question number 9. Question number 9, what do you think about that question? You're probably not liking the fraction very much, but is y to the 6th the perfect square? Sure. Is 1 over 225 a perfect square? It is. So I take the square root of my first term. That's my first term in each factor. One's a plus, one's a minus. Square root of 1 over 225 is 1/15. Don't be intimidated just because it has a fraction. Now, when you get down to questions 11 through 15, there may be multiple types of factoring involved. They may or may not include difference of two perfect squares. For instance, let's just look below at number 12. I see a difference. 28, however, is not a perfect square, nor is 7, nor is AB. But what I'd like to do there is use our technique from last night and say I do in fact have a GCF of 7A. So I would factor out my 7A and I would get 4A minus B. Now it might be the case that once you factor out that 7A, you could have had, for instance, 4A squared minus B squared. So in this case, you would not be done. You would have to go forward and do 2A plus B, 2A minus B, and that would all be multiplied by the 7A. So there may be multiple factoring techniques used in one problem. Go ahead and complete as many of those as you can. I will go through them momentarily. Take a look at the answers, and I'm going to target just a few of them to discuss with you. Number 5, don't get tricked. You're going to see that, and I have to remind you, you have to be mindful when you are factoring or really doing any kind of math. That is not a difference, therefore it's not the difference of two perfect squares. Nevertheless, we still need to factor it. Just because it's not the difference of two perfect squares, we still factor the problem. Moving along, the next one that I see that was kind of a little bit of an anomaly, shall we say, is number 11. That was not a difference of two perfect squares, it's just GCF. Moving along, I see two problems in the problems that remain. The first one is number 13. Usually you will see the directions for a factoring problem that look like this. Factor completely. That is not factored completely. That is not factored completely because this remains a difference of two perfect squares. We're not done. We have to keep going. So when we factor completely, we continue with the item that cannot be factored any longer, and then we add to that anything that can be continued to be factored. That being said, do you see the second problem? The second problem is number 15. We're not done. We had a GCF because this was not a D2PS to begin with. We didn't have a difference of two perfect squares, but this now is a difference of two perfect squares. So I need to go back, bring down my 8, and I get x to the 5th plus 2y and x to the 5th minus 2y. How we doing? We will take this and move forward with it tomorrow, and we'll be mixing it up in addition to just doing the difference of two perfect squares. Have a great night.